Year 7 and welcome to your third lesson in data representation, where we're going to be looking at images. Today's target is that you're going to be able to explain how images are represented in binary code. The first task you're going to complete is the connect task, where you're going to take part in a retrieval quiz. Number 1. Convert this binary number into denary. Number 2. What is a character set? Number 3. Which is the largest? ASCII, extended ASCII, or Unicode? And if you complete all those easily, please do the upgrade task, where you can list all the key terms from this quiz. You've got 5 minutes. Pause the video now. Let's go through the answers. Number 1. Convert this binary number into denary. The answer to that is 53. On number 2, what is a character set? Because computers work in binary, all characters, whether they're letters, punctuation, or digits, are stored as binary numbers. And all the characters that a computer can use are called a character set. So as long as you've got something along the lines of characters that a computer can decode, that's okay. And question 3, which is the largest? ASCII, extended ASCII, or Unicode? The answer to that one is Unicode, as ASCII has 7 bits, extended ASCII 8, Unicode has 16. Well done if you've got all them right. Let's move on. Today's main lesson objectives are to be able to explain how images are represented in binary, to know the difference between bitmap and vector images, and to be able to explain how resolution affects an image. The next task is an Activator task, where you're going to be doing a gap fill exercise. So you've got 5 minutes to fill in the gaps. Pause the video now. Okay, let's go through the answers. Images can also be represented using binary code. It's quite clever, so let's find out how it works. A bitmap image is made up of a series of coloured squares, or pixels. Bitmap image files are large, as every pixel is saved individually. A vector image is made up of a set of lines and shapes. Vector image files are small, as only the information needed to create the shapes is saved, for example the size, position and colour. Really well done if you've got all them right. If you haven't, just correct yourself and let's move on. The next Activator task we're going to complete is we're going to fill in this Venn diagram, including what are the similarities and differences between bitmap and vector images. Going to have about 10 minutes for this, so give it some really good thought, and I'd love to see your answers, so email me in your answers afterwards. Pause the video now. Let's go through some possible answers. So, bitmaps are different to vectors because they're made up of pixels. They have a large file size. They lose quality when enlarged or if you zoom in. They have a different file extension, and they do not convert to vector. Vectors are different to bitmaps because they're made of paths or shapes. They're a small file size. They don't lose quality when they're enlarged or if you zoom in. Obviously they're a different file extension to bitmap, and these ones can convert to bitmap. Some of the similarities are that they're both image file formats, so they can both display photos or shapes or paintings. They can both be read by a computer, and that's because they're both made by binary code. Let's move on. Okay, the next thing that we're going to be looking at is a video by the BBC looking at bitmap images. So at the end of this video, I want you to be able to tell me what a pixel is.
When writing your own computer program, you'll sometimes want to include graphics. I'm here with the pupils from the Eelsleys Primary School, so we can create our own computer graphics. You can create something known as a bitmap, and that's when you break the picture down into a grid of different coloured squares. Hi guys! So we've given you a stack of cards and also a grid known as a bitmap, and that has a series of zeros and ones. Every time you see a 0, that represents white. When you see a 1, that represents a black. So just turn over the cards when you see a 1 and then see what picture you get. We've got 2 different teams, and each team is working through a different bitmap grid.
0 up there, 1 up there.
When there's a 0 in the grid, they place the card white face up. When there's a 1, they place it black face up. We're using only zeros and ones to represent the information, and we call this binary. So a computer can represent graphics and pictures as a grid of numbers. Each number tells us the colour of one small square, called a pixel, and we build up the whole picture using a load of these pixels. Alright, so guys, how are you approaching this? How are you working as a team?
We're in the corners first, and then with the foot down.
So you're the director, you're telling everyone what to do, and then they place it. Oh, that's cool. Guys, wow, you seem to be doing pretty well. What's your strategy? Cool, so what do you think it could be?
I have no idea. It looks like antenna, I think.
You've lost where you're at. 1, 2, 3, 4, 5. You're on the 6th level up. Wow, you guys were super quick. That was awesome. So what do you think it could be? It's an alien. Do you all think that? A robot. What about computers? Think about the Space Invaders. I think that's right. Wow, you guys have done it as well. So what do you reckon this is? A dog. What makes you say that?
Because it's got the legs and the aliens kind of got the body shape.
Okay. Oh yeah, and there's a tail, I suppose.
Yeah.
Okay, no eyes though.
No.
But I've got to ask you, how come that leg down there, it seems by itself, is there black missing? So I reckon this one actually should be a black. I think it was a number 1. Now that looks a bit better, doesn't it? So guys, these look totally awesome. However, they do look rather blocky, and that's because the squares we're using are rather big. So I have some smaller squares, which are a quarter of the size, so you can fit 4 of these into one of the squares you've got at the moment, making it a bit smoother, and that's something we call higher resolution. A higher resolution picture contains more pixels, so there's more information and we can have more detail. And there are other ways to improve the picture too. Today we're only using 0 and 1 for white and black, but if we use more numbers, we could have different colours. When your computer stores a photo, each pixel could be any one of over 16 million colours. That's better already, can you see? It's actually less harsh, it curves a bit more. These edges are a lot smoother. Yeah, that's working really well. Cool. This is pretty impressive. Oh, you've even put the white bits in the ears.
Yeah, I thought if we could have even smaller squares, coloured, maybe pink inside, it would look even more effective.
Yeah, you could have the pink inside the ears, that would be great. So what do you think? Do you like it? Do you think it looks better? A bit smoother? It has a higher resolution. So guys, these look great. The smaller squares have improved it already, and if we were to go even smaller with the squares, we could make it much better. And if we were to add more numbers, not just the zeros and ones, we could actually add some colour too.
Okay, let's move on. In this week's demonstrator task, you'll be filling in the binary input section, copying the image to the left in the image section. The first row is already filled out as an example. After you've filled in the binary input section, you can then move on to the output image section. and colour each square or pixel the correct colour, following your code in the binary input box. Remember, 0 equals white and 1 equals black, just like in the video you've just watched. You have 15 minutes to complete this task. Pause the video now. Well done on finishing that task. Here's what you might find it should look like. So I've, as accurately as I could, replicated the image, and we still have a smiley face. The final task for today's lesson is to complete the Consolidate task, which is the Microsoft Forms quiz, by following the link below. Thank you for all your effort today, and I'm really looking forward to seeing your emails with some work attached. See you in the next lesson. Bye!